Now when you're selecting the tip that you want to use, there is a tip chart located in your United Association Oxy-Fuel Welding textbook, and it can guide you on what size tip you need for the thickness of metal. The metal that we're using today is 1/4 inch steel plate, and actually I'm using a little bit small tip for this, but I actually have some new tips for this that I got from the recent Skills USA, and I'm going to utilize these tips. They work for me. So I run it at a little bit more than half of its full load capacity, and it seems to do a good job. You also want to make sure before you begin the process that you have the proper safety attire on. You want to make sure that you have some good flame resistant or flame retardant clothing. You want to make sure you have your safety gloves on, and of course the appropriate safety glasses. Now I've got clear safety glasses on currently, and hopefully my film crew will remind me this time that I need to put on the appropriate shade number before I start the Oxy-Fuel welding process. The minimum shade for doing this is a shade number 5 for light welding, and it goes all the way up to a shade number 8 for heavy welding. Now, before we start this process, there's several things that we need to do to our tanks. Again, like I said, we've done before in the brazing video, but I'm going to go over it real quickly once again. Now, I went ahead and pre-assembled these tanks and tested to make sure that they're safe for use, and I've inspected my hoses. Now, that reminds me, another thing on these hoses. These hoses need to be readily identifiable from one. They've got to be distinguishable one from the other. And notice the oxygen has a green hose and the fuel gas has a red hose. Now, if you're using two separate hoses and joining them together and you're having to tape them together, you never want to cover up more than 4 inches for every 12 inches of hose. That way it will not be visually covered up and everybody will be able to distinguish between the two. Now, to the tanks themselves. I've tested these regulators, but before I installed these regulators and performed my pressure check on my heating unit here, I stepped to the side of the tank and I opened the valve abruptly and purge any dust or debris that's in this valve right here. And then I fix my regulator. Now I do the same thing on the oxygen. Okay, now the oxygen valve has a special double-seated valve on it. When you're opening the oxygen valve, you need to open it all the way to seat it on the other side of the valve. Like I said, it's a double-seated valve. Now on the acetylene, you only want to open it a half to a 1.5 turns, and this is in case of the need to emergently shut it off really quick to prevent fire or to prevent a catastrophic event. In case something's caught on fire or someone is actually on fire. Once again, we stood to the side, we purged the tanks. We don't want the debris, if there is any, in the valve to hit us in the face or in the eyes. The glasses are a safety measure, but they don't always prevent something from getting in your eyes, especially when it's at real high pressure. We've done it also with the oxygen standing to the side, opening the valve, which is referred to as cracking, getting a good purge and shutting it abruptly. That's cleared both of the valves of any debris. Then we affix our regulators. Okay? Once our regulators are fixed, this connection right here needs to be checked to make sure that it's leak-free. The last thing we want to do is sit here and be leaking gas out, especially in an enclosed space with poor ventilation. Now that's another rule that brings to mention. When you have these tanks, you want to make sure that you're in a well-ventilated area, and you never want to install these tanks in what's referred to as a confined space, where there's no ventilation. This gas can build up and cause an extreme gas flash once it's ignited, okay? And also breathing the fumes is not good for you as well. So, once we've installed these regulators, what we want to do is we want to stand to the side. Make sure your set screws are backed out. The set screws backed out turns off any pressure leaving these hoses and going to your torch. Now we do have pressure leaving the bottle going to the regulator when we crack these valves open. So I'm going to stand to the side, crack the valve open, which lets pressure build, and then I'm going to shut it. And again, I'm going to watch my gauges. I'm going to watch my gauge for a set amount of time, 15 to 30 seconds, of course, just depending on how much you have and how big of a unit you've got, and see that there's any drop. I know I've checked these that there's no drop on this needle, so I know there's no leak right here at this point. So this is closed. Make sure it's good and closed off. I'm going to do the same thing to the other one. I'm going to stand to the side, crack the valve, pressure builds. I'm going to shut it, and I'm going to watch my needle again, and I'm going to make sure that the needle doesn't fall, which is again checking this connection. Now, if this falls, we don't have any pressure leaving the hoses or going to the torches or these valves or this tip or anything. So the only place of leak could be on the bottle itself or the regulator, or more than likely it's going to be on this connection right here. So since we performed the checks on this, and I've already performed the check on my hoses for cuts, abrasions, grease, or oil. You never want no grease or oil around oxygen. It creates a fire and explosion hazard. You don't want them on your gloves, on your person, on the valves, on the tanks, on nothing. Also notice that I have my cylinders in the upright position like they're supposed to be, and they're secured in a special carrier that's designed for this. That way they're transportable around here in this facility, and it's safe not to have the cap secured. But if I'm finishing this up, or if I'm storing them somewhere, they need to be stored at a minimum distance of 20 feet apart. If I can't do that 20 feet apart, I can substitute that for a 5-foot, what I call a firewall, but it's a non-combustible material that has at least a 30-minute fire rating on it. And that will suffice for separating these two from one another. So anyways, I've leak checked this. Now I'm going to open the valve up on the acetylene slowly and then crack it open a turn to a turn and a half. The reason we open this slowly is because the gas is compressed in this tank. Once you open the valve, the gas expands rapidly and then it's forced to be compressed again in the regulator. And it's been known to send this set screw, this pressure adjustment screw, flying at someone's direction, and we don't want that to occur. So I've got this open. I'm going to run my pressure in and get 15 psi going, 14 or 15 psi. Never exceed 15 psi leaving this torch. But right now it's confined pressure, and I'm just checking to ensure the integrity of my hoses and my torch. And I'm going to do the same thing. I'm going to watch and ensure that the gauges doesn't drop once I've done that, because my pressure's leaving. I'm going to close my tank off, and now I've encapsulated that gas from the regulator to the hoses to the torch, making sure your valves are fully closed. And that way, if there's any leaks, it's going to have to leak at these hoses or at these torches if you've already proved that there's no leaks prior to letting the pressure leave the hoses, which we already done that. So once I've ensured that there's no leaks, I do the same thing to my oxygen. Stand to the side, open the valve all the way. Well, excuse me, not all the way yet. Right now we're just pressure checking. So open it, let the pressure build, run your set screw in. I like 15 psi. Close it, and then ensure that the needle doesn't drop once again. Now, if you're ever going through the oxy-fuel welding or brazing process or even cutting process, oxy-fuel cutting, if you ever do have a flashback, the pressure in which you check these hoses are going to be twice the operating pressure, because anytime there's a flashback, it can forfeit the integrity of your hoses, and you want to make double sure that there is no nicks, abrasions, burn-throughs, or anything of that nature. So, since our needles haven't dropped, we know that we're ready to begin the Oxy-Fuel welding process. Now, before we get started with that, I want to go over a little bit about this metal. This metal, it doesn't matter. This is just an example to show you how to do the process. This is 1/4-inch plate, like I said before. What I've done is I've cut this metal and I've beveled it at an angle. The reason I've beveled it at an angle is to give me the ability for my rod to get all the way down to the bottom so that I can weld from the bottom up. And that's referred to as putting a root pass in the metal. What I've got to do is not only do I've got to heat the metal up until it's reached its wetting or melting point, but I've also got to do the filler metal as well. So the right side of this metal, the left side of the metal, and the rod simultaneously all have to be heated up to their melting point so that they'll fuse together and bond. And I'm going to lay a root pass the entire length of this once I begin the operation. But before I start to lay that root pass, I'm going to do just a tack in the root. Same process, but I'm just going to do a small amount on the left side of the metal and a small amount on the right side of the metal. That way when I heat it, it doesn't pull to one side or the other.